Hello. Today we're going to do the first of two labs on a tool called Solver. Solver is a plugin to Excel, and it is used to do optimization problems. Optimization problems are very common in operations management and operations research. Here's a typical example. Let's say you have a truck, maybe for let's say Coca-Cola. Coca-Cola uses these kinds of problems a lot. You have a truck and it's loaded with Coke, and you need to make deliveries to several different places during a day, say 4 different grocery stores. So you have a truck and you have 4 grocery stores you have to visit. And the question is, what's the most efficient way to visit all 4 of these stores? And the most efficient way is basically the way that's going to minimize the total distance you travel. So the total distance you travel is going to be indicative of how much time you use and how much gas you use, etc. So you want to deliver this Coke to the 4 locations in the fastest way possible. Well, with 4 locations, we have a possibility of 24 different routes. You could go to store 1, then store 2, then store 3, then store 4, or you could go to 1, then 2, then 4, then 3, etc. And you can see by looking at these choices that 1, 2, 3, 4 is really the same as 4, 3, 2, 1. It's just that you're doing it backwards. So in terms of the distance traveled, they're the same. You're just doing it in a different order. So if I'm Coca-Cola and I want to figure out the best solution to this problem, I would just calculate the distances for all 4, or rather, all of these options for all 4 stores, and would figure out which one gives me the minimum distance. So with 4 different stores that you have to visit, what we have here are 24 different solutions. Okay, so 24 solutions would not take too long to figure out. We could just calculate the distance for all of these, choose the most efficient one. The problem comes when you have something like 10 locations or 20 locations. So with 10 locations, the problem is not as straightforward. And with 10 locations, you've got over 3 million possible solutions. So to go through 3 million solutions and figure out which one is the best possible one is a lot harder than figuring out the best possible one with 24 solutions. And so doing it, mathematically or in a basic tool like Excel is going to be pretty difficult to do, pretty time consuming. So rather than just looking at all the options and calculating the distance, we want to use some sort of a tool, some sort of an optimization tool that will tell us what is the optimum solution. What's the one best solution out of these 3 million that minimizes the total distance that we travel. So that's what Solver is going to do for us. It's going to solve these sorts of optimization problems where we have one solution and we're trying to figure out what that solution is out of many, many possibilities. So in Solver, there are basically 3 things that we're going to need to do. The first thing is we're going to set up the objective cell. The objective cell is the value that you are trying to maximize or minimize. So in this Coca-Cola example, we're trying to minimize the total distances. Typically, if you have an efficiency problem or a cost problem, you're trying to minimize cost or minimize resources consumed. If you're talking about revenue, then typically you're trying to maximize. The second thing is the variable cells. The variable cells are the values that you're going to change in order to come up with that one objective answer, that objective that you're trying to meet. What are you going to change in order to do that? And so in this case, we would be changing the order of the stops that we're visiting. And then lastly, what would be the constraints? And constraints are additional objectives that you have to meet while satisfying your objective. So let's say, for example, store number 2 has to be visited before 10 o'clock in the morning. And that means that store number 2 is probably going to have to be one of our first, say, 4 stops that we make. That would be a constraint that would limit the possible solutions that we could use. All right, so when we're setting up a solver problem, these are the 3 things we have to tell it. What's the objective? What are we going to change? What are the variables? And then finally, what are the constraints? So at this point, I'm going to jump over to Excel. So if you go to the Excel Labs folder on Blackboard, this is going to be Excel Lab number 4, and you're going to grab a spreadsheet called Production Plan L1 Start. That is this spreadsheet right here. So what we have here is we're back with our sporting goods company, and our sporting goods company is sponsoring a tennis tournament. And as part of our sponsorship, we are going to supply this tennis tournament with some of our rackets. So we're going to make rackets, and we're going to donate them to the tournament so that they can be used as giveaways, and so they can be used to give them to players and things like that. So here we have some cost information for these rackets. So we've got 2 models of rackets. We've got Model 1 and Model 2. Model 1 has a unit cost of $18 a piece. Model 2 has a unit cost of $28 a piece. And then we also have some production setup costs. So production setup costs are incurred no matter how many units we make. So if we make Model 1 rackets, we have a one-time cost of $975, and then we have a per unit cost of $18. With Model 2, we have a setup cost of $11.95 and a unit cost of $28. Down here we have some information about the amount of fiber that is used for each racket. So each racket is comprised of carbon fibers, graphite fibers, and Kevlar fibers. Model 1 uses 3 ounces of carbon, 1 ounce of graphite, and 2 ounces of Kevlar for each racket. So every time we manufacture one Model 1 racket, that's how much fiber we're going to use. And with Model 2, we have 4, 2, and 3 ounces of the various fibers. Finally, over on the left, we have some constraints. The constraints are additional parameters that we have to keep in mind when we're manufacturing rackets. So our first constraint is that the total cost of tennis rackets must not exceed $10,000. So we have a $10,000 budget, and we want to make as many tennis rackets as we can while not exceeding that $10,000 budget. That's going to be our goal. That's what we're trying to optimize. How many rackets can we make for less than $10,000? So we're trying to maximize the total number of rackets subject to that cost constraint. We also have some quantity constraints. We want to make at least 150 of each tennis racket. So we can see here that the Model 1 racket uses less fiber than Model 2, and it's also cheaper. So if we want to maximize the number of rackets that we make, the best way to do that would be just to make all Model 1 rackets, because we can make more for a particular cost. However, as part of our sponsorship, we want to send both some Model 1 rackets and some Model 2 rackets. So we want to make at least 150 of each. Then we've got total quantities of fiber. So in our inventory we have 1,205 ounces of carbon fiber, 485 ounces of graphite, and 891 of Kevlar. Every time we make a Model 1 or Model 2 racket, we're going to use some of that fiber. And so as we use that up, it's not going to be available anymore. So another constraint that we have is we cannot produce more rackets than we have raw materials to make. And then lastly, we have, this is called an integer constraint, and what that means is we only want to make whole rackets. So in other words, we don't want to make 175.1 tennis rackets. We want to make whole numbers of rackets because shipping a partial racket makes no sense. So that's our problem. Our goal is to maximize the number of rackets. We're going to do that by changing the number of rackets that we make, the number of Model 1 rackets and the number of Model 2 rackets. And we're subject to the constraints that are listed over here on the left. So to solve this problem, I'm going to use a tool called Solver. But before I get into that, what I need to make sure I do first is to set up the spreadsheet so that it has the correct formulas in it. Solver works based on formulas in Excel. If you don't have the correct formulas set up, then Solver is not going to work. So the first thing that we do whenever we have a Solver problem is before we get into the Solver tool itself, we need to look at our spreadsheet and make sure that it's set up correctly. So first, we're going to have carbon fiber used. Okay, let's pretend. Let's say that we're going to make 10 units of Model 1 and 10 units of Model 2. So I'm just going to type those values there in cells G4 and G5. Let's say we do 10 of each. So if we produce 10 units of Model 1, then if we look down here, Model 1 uses 3 ounces of carbon fiber for each racket. And so we should be using, if we're making 10 rackets, then we should be consuming 30 ounces of carbon fiber because each one has 3 ounces. So here in this cell, carbon fiber used, I'm going to have a formula that says G4, which is the number of rackets produced, times F12, F12, which is the number of ounces of carbon used for each racket. So if I do that, I should get an answer of 30. Similarly, with graphite, if I'm producing 10 units of Model 1, I'm going to use 10 units of graphite. So that's going to be G4 times G12. And then finally Kevlar is going to be G4 times H12. I need to do the same thing for Model 2. So if I take these cells and I just drag them down, drag those formulas down, then I'm going to copy those formulas for Model 2. So now all of these cells are going to be G5, which is the number of Model 2 rackets, times the fiber used per racket for each of these types. So this carbon fiber is going to be G5 times F13. Graphite is going to be G5 times G13. And Kevlar is going to be G5 times H13. All right, total cost. The total cost to produce Model 1 rackets is going to be my production setup cost, which is $975, plus the unit cost, which is $18, times the number of rackets that I make. So my total cost is going to be B4 plus, and then parentheses, C4 times G4. Okay, 975 plus 18 times 10 in this case. And so with 10 rackets, we have a total cost of $1,155. For Model 2, our total cost is going to be B5, which is the production setup cost, plus C5, which is the unit cost, times G5, which is the number of units. and then my sum total cost is going to be just the sum of these two. So I'm going to sum H4 through H5, or I could just say H4 plus H5. Okay, so my total cost is going to be $2,630. Now I want to make sum totals for these other cells as well. So my sum for carbon fiber is going to be the sum of D4 and D5, and then I can just copy this over to get the sums for these other cells. So basically everything in this row is going to be a sum total, everything in row 6. So I've got a sum for carbon fiber used, graphite used, Kevlar used, number of rackets produced, and then total cost. All right, and these are numbers for a quantity of 10 rackets apiece. If I clear out the 10, then all of these values are going to disappear because all of these cells that we just filled in are based on cells G4 and G5. Okay, so every time we change the number of rackets that we make, all of these other values are going to change. So now we have our spreadsheet set up correctly, and now I can go into Solver. To get into Solver, I go to my Data tab, and when I come over to the right, there is a menu in the upper right corner called Solver. Now if you do not have this, let me show you how to get it. So on a PC, if you go to File and then Options, you're going to get a box that contains Excel options. You're then going to go to Add-ins, and here you're going to get a list of the available add-ins. There's this box called Manage Excel Add-ins. You're going to click the word Go, and then you're going to get a list of available add-ins. And so Solver should be one of these available add-ins. So select the one that says Solver Add-in and say OK. Now if you're doing this on a Mac, you're going to need to do something similar, but the menu path to get to the add-in is going to be a little bit different. And also the way that Solver looks on the Mac is going to look a little bit different as well. Most of the concepts are the same. There's going to be one extra step that you're going to need to do, which I'll go through. After you've added Solver, you should see it on the menu, okay, on the Data tab. So I'm going to click that. All right, and this is where I put in my Solver parameters. There are, as I stated earlier, 3 things that you have to put in. You have to put in your objective, you have to put in your variable cells, and then you have to put in your constraints. So first thing is I'm going to put in my objective. Now my objective here is to maximize the number of rackets that I'm making. The total number of rackets that I'm making is here in cell G6. Okay, G6 is the sum of the Model 1 rackets and the Model 2 rackets. So that's what I'm trying to do. I'm trying to maximize G6. So I'm going to set my objective to G6, and then I'm going to click on this button for max. Max is the default. So if you're trying to maximize, that'll be the default. In cases where we're trying to minimize, you would choose minimize. In some cases, you may be trying to reach a specific value, and then you would choose value of. But in all the examples we're going to do in class, we're going to be either maximizing or minimizing. So I'm going to choose max. Next, what are our variable cells? Well, our variable cells are going to be the number of Model 1 rackets we make and the number of Model 2 rackets that we make. Those are the things that we're going to change. So I'm going to go to my variable cells, and I'm going to click in there in that thing that says by changing variable cells, and then I'm going to come up here and I'm going to select G4 through G5. And so I'm going to select both of those cells, or I can type them in if I want to. But that's what I'm going to change. All right, finally I've got the constraints. And the constraints are the trickiest part of using Solver. My constraints are over here on the left. So my first constraint is that my total cost has to be less than $10,000. Well, on Solver, or rather on my spreadsheet, my total cost is here in cell H6. All right, that's my total cost. So that has to be less than $10,000. So I need to add that as a constraint. To add a constraint, I'm going to click on this button that says Add. And then I'm going to put in what's my cell. Okay, my cell is H6. And then I'm going to choose either greater than, equal to, or less than. And then my constraint is going to be whatever my constraint is. And so my constraint is $10,000. So I could type in the number 10,000. Fortunately, I've already got the number 10,000 here in this cell, C10. So I'm going to click on C10. And so this constraint says H6 is less than C10. And I'm going to hit OK. All right, so notice basically what this means is Solver's going to try to come up with a solution to our problem. It's going to try to maximize G6. It's going to change G4 through G5 until it comes up with the best solution possible. But that solution has to be such that H6 is less than C10. So in other words, my total cost has got to be less than $10,000. That's what that constraint means. Next, I'm going to do a constraint for the number of rackets produced. My constraints over here tell me that I need to make at least 150 of each. So I'm going to add a constraint. My cell reference is going to be G4 through G5. And this time I'm going to say greater than or equal to, and I'm going to type in 150. I can constrain both of these to be greater than 150. I can constrain both of these cells to be greater than 150 because both of them have to be bigger than 150. If they had to be, if I had a different number for model 1 versus model 2, then I would need to specify those separately. But since they're the same number, I can combine those constraints like this. I'll say OK, and that'll get me back here. All right, next I've got some inventory constraints. My total carbon fiber has to be less than 1205. My total carbon fiber is right here in cell D6. So I'm going to add a constraint. D6 is less than or equal to 1205, which is right here in cell C13. Now this time, instead of hitting OK, I'm just going to hit the Add button, and the Add button will just prompt me to enter a new constraint. So my next constraint is going to be my graphite fiber used, which is in E6, is less than or equal to my total graphite fiber, which is in C14. I'll hit Add again. And then the total Kevlar fiber used, which is F6, is less than or equal to my total Kevlar fiber here, which is cell C15. Then I have one last constraint, which is my integer constraint. I want to produce only whole numbers of rackets. So to do that, I'm going to select my variable cells, which are G4 and G5. And instead of choosing less than or equal to, or greater than or equal to, I'm going to choose integer. Okay, this option in the middle that says int. And that's going to constrain my cells to be integers. Then I'm going to say OK. All right, so now I have my objective, I have my changing cells, and I have my constraints. Now in the current version of Microsoft Office, so Office 2010, Solver comes with this checkbox that says make unconstrained variables non-negative. And so what this means is the variable cells cannot be less than 0. Solver will not insert values less than 0 into those cells. Now, if you have an older version of Solver, or if you have Solver on a Mac, if you're using Solver on a Mac, you may not have this checkbox. So if that's the case, then you're going to need to add an additional constraint that makes the number of brackets produced greater than 0. So I would say add. I would then choose my variable cells, and I would say greater than 0. And the reason that we have to do this is because sometimes we might want to allow negative values into a solution. With the production problem like this, that wouldn't make sense. So we don't want negative values in there, but there may be some circumstances where you'd want Solver to stick negative values in. And so if we don't want it to do that, we have to tell it that explicitly. All right, and then we have a solving method. The default solving method is GRG nonlinear. For the problems that we're going to do in class, we're going to choose simplex LP. LP stands for linear programming, and this is just a mathematical technique that's used for doing these sorts of optimization problems. GRG nonlinear may work, but we know that simplex LP is always going to work for us. So now that I've got my my solver problem set up, I can hit the button that says solve. And here's what it tells us. It tells us solver found a solution. All constraints and optimality conditions are satisfied. And then it asks me, do I want to keep the solution or do I want to go back to the original values? Let's say I'm going to keep the solution, and I'll say OK. All right, so let's look at this. The solution that Solver came up with was to produce 185 units of Model 1 and 150 units of Model 2. So with this solution, this solution has a total cost of $9,700. That is below my cost constraint. I'm making at least 150 of each racket, so that constraint is satisfied. And if I look at the total amount of fiber used, I'm using 1,155 ounces of carbon, and I've got 1,205, so that's okay. I'm using 485 ounces of graphite, and I only have 485 ounces of graphite, so my graphite appears to be the constraint that is stopping my problem. So in other words, I can't make any more tennis rackets than this, because if I do, then I'm going to be using more graphite than I actually have. And then finally, Kevlar, I'm making 820, I'm using 820 ounces of Kevlar, and I have a total of 891. Now let's say, for example, instead of making 150 units of Model 2, let's say I make 155. Okay, so if I type in 155 here, okay, now let's look here. My total cost is still $98.40. It's $98.40, so that's still below 10,000. My carbon fiber is still below 1205. My Kevlar is still below 891. However, I'm using 495 ounces of graphite, and I've only got 485 ounces in inventory. And that's why this solution is not going to work, because that violates my total graphite fiber constraint. All right, let's clear this out. I'm going to clear out my my totals here. Okay, so I'm going back to my default. Now let's do the solver again. So if I click on solver again, I should have all of my same stuff in there, unless I've closed the spreadsheet and not saved it. Anytime you're working in solver, if you close it and open it back up, all of the things you specified will still be there. I'm going to now do solve again. It's going to fill in my answer again. This time I'm going to choose this thing called, I'm going to create an answer report. And then I'll say OK. All right, here's my solution. Now if I go to this answer report, basically the answer report tells me everything that I did in Solver. So it tells me here's my objective cell, here's the original value, here's the final value, here are my variable cells, and then here are my constraints. Notice it tells me here which constraints are binding and which are not. So with this one, it tells me here my total graphite fiber is my binding constraint. So in other words, the amount of graphite is what's stopping me from making more rackets. My carbon fiber and Kevlar and total cost are not binding constraints. Here it tells me I've got a slack of 300 for total cost. That means I have $300 left, essentially, before I've hit my cost constraint. And it also says that the number of rackets produced for Model 2 is a binding constraint. So in other words, I don't want to make any more than 150 in Model 2 because Model 2 is more expensive. The other thing that can happen is if you create a solver problem like we've done here and you go to solve it, and you may get the answer that there is no possible solution for this problem. So let's say, for example, I change my total cost constraint from 10,000 to 5,000. If I clear out my number of rackets produced, and then I go to solve this problem, okay, I haven't changed anything else in the way that it's been set up. The only difference is now instead of a $10,000 ceiling, I've got a $5,000 ceiling. So now if I hit solve, I'm going to get this big red exclamation point, and it's going to tell me Solver could not find a feasible solution. Okay, and that's because Solver can't come up with a solution that satisfies all of these other constraints without going over the $5,000 limit. So you can see here I've got a constraint that says I have to make at least 150 of Model 1 and 150 of Model 2. If I put in 150 of Model 1 and 150 of Model 2, already I'm at $9,000. Okay, so basically I'm asking Solver to come up with a solution to a problem that doesn't really have a solution. And so if you do that, Solver is going to tell you, I can't find a solution. With our original set of constraints, so a $10,000 cost limit, Solver should be able to find a solution. So if you went to solve your problem and you did not get a solution, then that means one of two things. Usually, probably 75% of the time, it means that something that you've set up in the spreadsheet itself is not correct. So in other words, one of the formulas that you entered is incorrect. So go through and double check your formulas and make sure that they're all set up correctly. If your formulas are set up correctly, then probably what that means is something is set up incorrectly in Solver. Either the objective cell or the variable cells, or probably more likely one of the constraints. Solver is a little bit delicate, so you can see right here I've got my objective cell is G6. Well, if I just happen to click somewhere else on the sheet, then it's going to replace my objective cell. So it's fairly easy to make mistakes. So just make sure that you have everything set up in Solver before you solve your problem. Alright, so this is the first type of solver problem that we're going to do. This is a maximization problem, and in our next lab we're going to do a minimization problem with Solver.